Good morning, dear students. Let us start the new lesson in physical chemistry. The name of the lesson is Ionic equilibrium. Ionic equilibrium. As you studied in 11th standard, equilibrium, chemical equilibrium, you have studied just recording about the chemical equilibrium. For example, when A and B are reacting to the C and D, what is called equilibrium first of all? Equilibrium is a state in which the rate of the forward reaction is equal to the rate of the backward reaction. That is called a state of equilibrium. Okay. What it means when A and B are combined to give us C and D as a product, how much faster the C and D is formed? The same speed. The C and D are compared to give back A and B. That means the rate of the forward reaction that is equal to rate of the backward reaction at an equal rate. That point is equilibrium. Okay. In ionic equations also you may find the equilibrium that is called ionic equilibrium. For example, if you take an acid, for example, I am taking acetic acid. This acid, when it dissolved in water, you are getting an acetate ion. CH3, CO minus plus hydrogen. Acetate. There is a equilibrium exists between dissociated and undissociated particles. See, acetic acid is dissociated to acetate ion and H plus ion. There is a equilibrium exists between these two. It may be reactant and this may be a product. There is a equilibrium exists. This is called ionic equilibrium. If you enter into the ionic equilibrium, you need to know some special concepts. Among them, acid bases are very, very important. Okay, acid bases. In our body metabolic process, many acid base reaction ionic equilibrium existed. For example, the equilibrium reaction between the carbonic acid and a bicarbonate buffer in a blood. It's a very, very important ionic equilibrium reaction taking place in the blood. See, H3O plus, what is called H3O plus? This is nothing but a H plus ion. H plus ion is very eager to form a hydrated form. When H plus ion treating with the water, it will give you a H3O plus. Both are equal. Okay. It is very easily form the hydrate. It is adding with the water, always exists as a hydronium ion. So that ionic equilibrium reaction, hydronium ion treated with a bicarbonate. That is a carbonic acid. This is called carbonic acid, H2CO3. When it releases the H plus ion here and forming the HCO3 minus. This is called a bicarbonate. This is called a bicarbonate. Bicarbonate. There is in the blood this ionic equilibrium exists. If you write this hydronium ion plus bicarbonate, you are getting the carbonic acid plus water. So in this lesson, let us see what are the acid, what are the bases, what are the different definitions for the acid and bases given by the scientists. For example, Arrhenius concept and Bronsted-Lowry concept and Lewis concept. Today, our target to see how the definitions given for acid based upon the Arrhenius and Bronsted-Lowry and Lewis. One by one we can see. At the earlier stage, you have studied what is acid, what is base. You may study that how you can identify. If sour in taste, that is called acid. If bitter in taste, that is called the base. That you have studied. And if you testing the acid and bases in your lower sections, how you can test the litmus paper. That is, it turns the blue litmus. Acid turns the blue litmus to red. Okay, and the bases turns the blue litmus to red, that is acid, whereas a base that oppositely it will take that is a red litmus to blue, and a bitter taste for base. These already you have studied in the lower sections. Now you are in the higher classes, how you can define. That is based on the concepts given by the scientist. First one is based on the Arrhenius concept we are going to discuss. What is acid? What is this? Arrhenius concept that we are going to discuss. Arrhenius. It's a simple way. What Arrhenius says. According to Arrhenius, the substance which give H plus ion, they are called acid. Simple. The substance, for example, if you take any substance that furnishes H plus ion in water, for example, if you take HCl. HCl in water, aqueous form, water, it releases the H plus ion to water. What happened to the water? It will become a H3O plus. As earlier I said, it will form a hydronium ion, H3O plus, and then Cl minus. This is a statement. What is according to Arrhenius? Any substance if you take, when it furnishes H plus ion, okay, when it furnishes H plus ion, in the book it will given H plus, both are same as earlier I said that H plus or H3O plus both are same. Okay, H plus. Now the HCl is generating H plus ion, so it is acid. According to who? Arrhenius. According to Arrhenius, if HCl releases H plus ion, it must be an acid. Okay. Likewise, take one more acid, H2SO4. H2SO4. Check water. What is that mean? This also will generate the H plus ion. And the plus HSO4 minus. According to Arrhenius, what is the acid? Acid is a substance which generates or releases H plus ion in aqueous medium or in water. Okay. They are giving an explanation that H plus ion in aqueous solution is highly hydrated. In the introduction class itself, I am mentioning that it is highly hydrated. What is hydrated? It is added with water. Water is added to something that is called hydration. Hydrated. It is highly hydrated. As usually, it is represented as a H3O plus hydronium ion. We need to call that it is called a hydronium ion. Or simplest hydrated form of proton, H. This is a way to write how the hydration takes place. H2O. We use both H plus or a HO3 plus. If we can use H3O plus or H plus, both are representing the hydrogen ion only. So, what is Arrhenius concept? Arrhenius concept is nothing but a substance which releases H plus ion. That is called acid. Then what a definition is given to the base? Simple thing, that is, if furnishes OH minus ion, that is base. According to Arrhenius, acid, the substance which releases H plus ion. In the same way, base is the substance which generate OH minus ion. There is hydroxyl ion. in water, that is called a base. For example, if you take NaOH, if you take NaOH, when you dissolve in water, you are getting Na plus OH minus OH minus. See, NaOH is the substance, it is releases the OH minus ion. That's it, is a basic substance. According to whom? According to Arrhenius. Now you can simply define any substances in water gives H plus ion, that is called acid. Any substances which give a OH minus ion in a water, that is called a basic substance. One more example, if I write a calcium hydroxide, CaOH plus calcium hydroxide. Calcium hydroxide in water, it will produce. There is a equilibrium exists, so I am giving a equilibrium symbol. In water, it will give a Ca2 plus 2OH minus 2OH minus. We said 2 already here. CaOH twice, so it generate 2OH minus. Okay, now it's clear. According to Arrhenius, what is called acid, what is called a base. According to Arrhenius, it is simple thing to recall. Any substances which release H plus ion, that is called acid. Any substances which release OH minus ion in water, that is called a base. Okay. Then there is a limitation for any concept, any limitation or drawback we can tell. Okay, what is the limitation of Arrhenius? What is the limitations of Arrhenius? See, the first limitation is that it does not explain the behavior of acid and bases in non-aqueous solvent. Non-aqueous solvent. What is called non-aqueous solvent? The solvent other than the water, they are called as a non-aqueous solvent. And say, what is the definition given by the Arrhenius for acid? Any substances in water releases H plus. It does not explain about the non-aqueous solvent. If it is not a solvent, is not at all water, how you can decide whether it is acid base? We cannot decide. According to based on the Arrhenius, there is a limitation. For example, non-aqueous solvent other than water, you can say acetone. What is the chemical formula for acetone? Can you say that? You can recall what is acetone? Acetone is a non-aqueous solvent. What is called non-aqueous first of all? Other than water, the solvent other than water is called a non-aqueous. For example, acetone. Then there are tetrahydrofuran. What is called tetrahydrofuran? You must know the structure in organic lesson. The introductory lesson you have studied the what is called the furan first. Let me explain what is called tetrahydrofuran. Before going to tetrahydrofuran, you should know what is the furan. Furan is a heterocyclic ring in which this is called the furan. This is not a tetrahydrofuran. This is called the furan. If it is removed, all the added by 4 hydrogen, if you add it here, this is called tetrahydrofuran. Tetrahydrofuran. In symbol, they TH. Done many times. You need to come across chemistry THF for a tetrahydrofuran. The structure is like this. What is the difference between these two, sir? Nothing but 4 hydrogens extra. If you add a 4 hydrogens, so this is called a furan. Furan, when adding a 4 hydrogen, see, one here, one here, one here. So the double bond is removed, thus you are getting a tetrahydrofuran. So this non-aqueous solvent, you cannot explain the aqueous thing. When you using the aqueous, that is water you can say this is coming out, so it should be acid. OH is coming out, it should be a base. But if you're using non-aqueous solvent like acetone or furan, you cannot determine the substance whether it is acid or base. This is one of the limitations of Arrhenius concept. So we can say Arrhenius didn't give any explanation if you change the solvent. That's it. Okay. We cannot use always water as a solvent. There are other solvents also there. If you use other solvent, you cannot find that is acid or base based on the Arrhenius. Then next, this theory does not account for the basicity of a substance like ammonia, which does not possess any hydroxy group. See, ammonia is a base, as you know very well. Ammonia is a base. If it is a base, according to Archimedes, what is think that OH should be there. There is no OH at all. You cannot say basicity of ammonia. You cannot give. These are the limitations of the Archimedes. It should be used for the aqueous only. If you use the solvent as a non-aqueous, other than the water, you cannot decide or determine or find out whether it is acid or base. In the same way, you cannot give a ammonia, basicity of ammonia, you cannot give ammonia, that means you cannot give. There is no OH group. Okay, now let us see the evaluate. Evaluate yourself. I will explain you how, based on the Arrhenius concept, how you are finding this list. They have given a list of substance. You find that whether they are acid or base. Okay. What is in the list first given? Number 1, HNO. Okay, let me try. HNO is acid or base. Nitric acid is simply acid. Okay, let it be. We are following it. We are applying the Arrhenius theory there. What we can get? HNO3. HNO3. H plus ion and the NO3. So what is the thing? It is an acid. First one is an acid. This is acid. Beginning result. Okay, what is the next? Next, BaOH twice, barium hydroxide. Barium hydroxide. BaOH twice, barium hydroxide. When you apply in the Arrhenius factor, you get a B2 plus 2 OH minus. So when I am adding a water, in a water, barium hydroxide generating the OH minus. What is the nature of this barium hydroxide? It is a basic substance. This is a basic substance. Then let us move on to the next. What is that? H3PO4. 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 The name of this H3PO4, phosphoric acid. Still more detail if you study in inorganic, orthophosphoric acid. The name itself we are getting that it is acid. It should give a H plus ion. It will give a H plus first. Then it will give you H2PO4 means H2PO4 means H3PO4 phosphoric acid. Phosphoric acid also generating the H plus. So what is that H3PO4? It is an acid. It is an acid. Then acetic acid very often we discussed, even though for the exam purpose we are writing acetic acid CH3. Acetic acid. When you apply it, dissociated into water. It will be acetate ion CH3 COO minus plus H+. So thus, by applying Archimedes, this last CH3COH also, you are getting that as RC. Now we have evaluated all the 4 subdivisions. HNO3 is acid because it's generating the H plus ion. Likewise, barium hydroxide is a base. Why? Because it is a base. It is a base since it produced the OH minus. Then H3PO4 is a phosphoric acid, phosphoric acid. From the name itself, the acid is there, but we are applying it also generating the H plus. So it is a acidic substance. Then acetic acid that also producing H plus ion. So that is acid. So given among the 4, HNO3, nitric acid is acid, barium hydroxide is a base, H3PO4, phosphoric acid is a acid, acetic acid is a acid. That is. Okay, now it is clear what is acid, what is base, based on the Arrhenius concept. Okay. Then let us see the Lowry-Blanchard theory. That is the same for acid and base. What is he is giving? So according to Lowry-Blanchard theory, it is what is acid, what is base. Simple thing is that if it gives a proton, that is called acid. That is a protonic concept. Lowry-Blanchard theory is nothing but a protonic concept. The substance which generate or releases proton, that is called the acid, which accept that proton, that is called a base. Okay, according to Lowry-Blanchard theory, the substance which donates proton, that is called acid. Okay, substance which donate the H plus ion, that is called acid. The substance which accepts, okay, the accepts proton, they are called a base. So they are given as a base is a substance, basic substance is substance which accepts, the tendency has to accept the proton. Okay. Accepts H plus ion. The substance which accepts the H plus ion, that is called a basic substance. Okay. One word, if accepts a proton, that is called a base. It donates or releases the proton, that is called a base. For example, if you take the reaction between the H2 water plus HCl, you know real what is going to happen. When it is treated, both of them treated, you are getting the H3O plus. Sir, first you are writing H plus, now you are writing H plus. Both are same. Already I said, instead of the H plus, you can write H3O plus. This is the product. Cl. Now, question is that which is acid, which is base? The reaction is given to you. H2O plus HCl gives H3O plus. See. According to Blanchard-Lowry, what is a which donates the H plus ion. Now I am going to see from this reaction where is the proton is donated, where is the proton is accepted. Okay. See here, HCl is becoming Cl minus. What happened to HCl? HCl is becoming a Cl minus. It releases the H plus ion. Releases the H plus ion. So according to the theory, what is called H plus HCl is an acid. Good. Then who accepts the H plus? See what happened to H2O? H2O accepts the H plus ion from HCl. It is becoming a H3O plus. I told you. So this is a base. Now is theory is clear. Since HCl is releasing the proton and H2O is accepting the, so this is the base. This when an acid is releases the H plus ion, it will become a base. When a base accepts the H plus ion, then it will become a base. This is the base. Now it's clear. See what things. This is acid. Why it is called as acid? It releases H plus ion, so it is acid. After releasing the H plus ion, it will become Cl minus. This is called base. That is a conjugate base of the acid. Likewise, what is the base? Water is a base. Water is an amphoteric substance that you know very well. Amphoteric means what is called amphoteric? Amphoteric means it can behave as a both acid and a base as well as base. In the place, with respect to the place, it can act as a both acid and base. It's an amphoteric substance, water. Here, it is acting as a base. This is the So the acid, when it releases the proton, it will become a base. That's called acid base conjugate acid or conjugate base sequence. It's clear. Then let us see that there are some more examples. It will be more clear. We can go ahead. Conjugate acid base pair. What is this? A conjugate acid base? The same reaction. If you see no, the same reaction, you can get it. See, HCl is acid. Why it is called acid? This is acid. Why it is called acid? It releases the H plus ion. Okay. It releases the H plus ion and becoming like a Cl minus. It releases the H plus ion. After releasing the H plus ion, it behaves as a base. So the acid, the conjugate of that acid is a base. So these two are called a conjugate acid base. Here water accepting the hydrogen, it will become a base. Okay, this is a basic substance. And after accepting the H plus, it will become a acid. Because of the accepting, it behaves as a basic substance. After that, it will behave as acid. So acid base. This is called a conjugate acid base. Till more examples, if you work it out, it will be very easy to calculate. NEET also, NEET and theory also, there are a lot of questions relevant to that conjugate acid base pair. Okay. Okay, let me explain with before that, explaining the conjugate acid base theory, conjugate acid base concept. Let me see the what are the theoretical explanation they given HCl and Cl minus. See HCl and Cl minus. HCl and Cl minus are HCl and Cl minus. That is a conjugate acid and its base. Likewise, H2O and H3O plus. This is a base that is conjugate acid. What is the limitation that we are going to see? The branched acid. Okay. Already we have seen is saying that H plus and OH feeling. Then somewhat alternative is in branched theory. Branched theory based on that protonic acid. Sir, there are many substances do not having the involving into the protons. For example, BF3. For example, BF3. There is no H plus proton. How you can say whether its releases are accepting the proton. Likewise, AlCl3, aluminum chloride. Here also there is no proton involved. So far we have seen the example of HCl, H is there. Like that we have seen water, H2O, OH is there. But here, these cases, you cannot explain the acid and base. Whether it is acid or base, you cannot use that branch of theory. That is important. Non-protonic parts. If there is no proton, you cannot explain branch of acid base theory. That is the limitation. Substances like BF3 or AHCl, etc., they do not donate proton or known as to behave as acid. This is acid. Okay, there is other theory to explain why it is called acid. There is no OH, there is no H plus, there is no proton transfer. So these two theory cannot explain this is acid or that is acid. Based on those theories, it cannot be explained. So that is a limitation. See, each and every theory they have its own limitations. By using all those theories, we can find the solution. We can finalize the solution. This is acid or this. We need to apply all those three. Okay, in those cases, BF3 and AlCl3. So how you are explaining this is acid? Let me see the next concept that we are going to see. Lewis concept. In that, I will explain that how it is acid and this. Okay. Now let us see the evaluate 2. In evaluate 2, what is that? Write the balanced equation. Write the balanced equation for the dissociation of the following in water and identify the conjugate acid base. Okay, let us do this. First one. Evaluate part 1. NH. What they are asking? Like the acid base, conjugate acid base based on the branch of Larry. Okay. NH4. What is called NH4? NH4. Ammonium ion, not ammonia. This is not ammonia. This is ammonium ion. Ammonium ion. Okay. Ammonia is different from ammonium ion. Ammonium ion. Ammonium ion. So when you dissolve water, there is a question. As dissolved, what is going to in reaction? Plus H3 CDS student here proton is released. What happened to NH? What happened? NH4 plus becoming NH3. Proton is released. It is proton released. Okay. What happened? Proton released mean according to Lewis. What happened to the basic sections? What is happening here? H2O becomes H3O plus. One more hydrogen is added. Here hydrogen is released. Here hydrogen is accepted. Now it is donating the proton. Since it is donating the proton, let me call it what this is acid. Because according to Brown-Lowry, what is saying that the substance which releases the proton or donates the proton, it donates the proton, then it will become a acid. So what is the conjugate base? This is the conjugate base. Ammonia is a base. Because ammonium ion becomes ammonia. After releasing proton, ammonium ion is becoming a ammonia. Likewise, let me see this. H2O. What is happening? H2O base. Why it is a base? Since it accepts the proton to form, so it is a base. After accepting, what is H3O plus? This is an acid. So, what is the conjugate? Question may be asked. What is the conjugate base of ammonium? In which for what is the conjugate base? This is a conjugate base is ammonium. Likewise, what is the conjugate acid of water? H3. Then H2O and the H3O plus are conjugate acid base. Okay, acid and base. This is the base and acid. Likewise, acid and the base. Okay, it's clear for you. The evaluate one. In evaluate one, what is happening? They are given ammonium ion. What they asked to write the valence equation for the dissociation of the following water. Water they are given. I am taking ammonium ion and dissolve it in water, H2O. After dissolving in water, what I am getting? Ammonia and a hydronium ion H3O. This is a completely balanced reaction. I am mentioning the conjugate acid base. Okay, like this, you can write that for H2SO. This is one reaction. Equation 2. Let us try to write. What is that? Sulfuric acid. What is the question diagram? When a sulfuric acid H2SO4, it is treated with the water H2O. What is going to happen? HSO4 minus HSO4 minus plus H3O plus H3O. See, dear students, what happened to H2SO4? H2SO4 releases the H2SO4 releases so much. Okay, donates so much. So this is acid. Acid became HSO4 minus. Acid, that is conjugate base of that acid. So what happened to water? The same reaction. Above we have seen H2O becomes H3O. H2O accepting the proton. It accepts the proton. Since it accepts the proton, it gaining the hydrogen accepts the proton. This is a basic substance. This is a base. After accepting, what is happening? That is H3O plus. That is acid. So water is a base. That's conjugate acid is hydronium H3O plus. Okay, like that you can write remaining. Let me read. First, acetic acid. We try that for acetic acid. What is there in acetic acid? Try. For acetic acid. 3. What is the formula for acetic acid? CH3. COOH. Acetic acid. In water. What is going to happen? Acetate ion. Acetate ion CH3. COO minus plus. So acetic acid become acetate ion. So what is there? It releases the protons. So since it's acid, it is a conjugate base of the acid, acetate ion. And the H2O is a base, it accepting the H plus ion. So this. So what is the conjugate acid base? So that's all about the Brand-Lowry concepts of acid and base. What they are explaining, sir? Brand-Lowry and Lowry, they are given an explanation about the substance which are having which are donates the proton, that is H plus ion. Proton is nothing but a H plus ion. They are called acids. The substance which are releasing the H plus ion, they are called acid. The substance which accept, they are called base. For your knowledge purpose, I am saying that the conjugate base of weak acid is strong. Okay, so you know very well the acetic acid is a weak. The conjugate base acetate ion is very, very strong. Okay, in the higher classes, in the next topic, you will study that how you can decide that based on the conjugate acid base. Whenever the the strength of acid, that tomorrow class we can see. Need not confuse. Just today, what else you are seeing that Bronsted-Lowry concept. According to Bronsted-Lowry, the substance which donate or releases proton, they are called an acid. The substance which accept the proton, they are called a base. Okay. Let us see the next thing. That is a Lewis concept of acid and base. What is the next concept we are going to see? Lewis concept. Lewis concept of acid and base. Lewis concept of acid and base. According to Lewis concept, what is the electronic concept? See, easily you can recall. Arrhenius H plus and OH. We dealing with the H plus and OH. Whereas Bronsted-Lowry, we are dealing with the protons, proton acceptor, proton. Now the same way, Lewis is giving the electronic concept. Okay. The electronic concept is still more. Let's see, some substance they do not have H plus and OH. That we cannot explain the acid or base based on that arguments. Likewise, there is no proton involved at all. The substance they do not dissolve into water. You cannot give an explanation with the Bronsted-Lowry. So these are the defects or limitations of these two. From this, now you are getting the Lewis concept. In order to come over from those defects, Lewis is giving the some other concept based on the electron. Okay, this is based on the electron. Simple, the electron mass, the substance which donate the electrons. Okay, the electrons, substance donates the electrons. Pair of electrons, that is called a base. They are base substance. We can call it as a base. The substance which accepts the electron, pair of electrons, then that is called S. This is concept given by Lewis concept. What is the concept of Lewis? The simple way to recall Lewis concept, based on this electronic concept, based on the substance donates the pair of electrons, they are called a basic substance. If the substance accepts the pair of electron, they are called a acids. Okay. So from this, you can come to know that if you want to donate money, you should have more money. This is a basic thing. Likewise, the element or substance which are having the more electrons, they can act as a Lewis base. According to Lewis, they are having the pair of electron, that is a lone pair. Lone pair means that a pair of electron which is not involved in any bonding. It's called lone pair. So they are called, they can, that is a quality to act as a Lewis base. If they donate, then they are called a surface. Then accepting the electron diffusion. If both rich people, they will not get together. Okay, they will not get donating each other. If there are donor, there should be some acceptor should be there. Well, what is the qualification of acceptor, sir? The quality of the acceptor, they should possess some vacant place in them. Okay, if they are having the vacant place, then they can act as a Lewis. For example, BF3. If you take a BF3, is electron diffusion pieces. BF3. Okay, BF3. When it's treated with ammonia, you are getting the ammonia having the lone pair electron. It is donated to the vacant BF3. As a result, you are getting coordinate bond between that BF3 and Okay. See, there is a new type of chemical bond formed between the BF3, BF3, that is not aromatic. What it means, sir, here the lone pair of electron ammonia is donated to boron. So boron having, let us see, before that the electron configuration of boron, if you write boron, what is the atomic number? 5. What is the electronic configuration of boron? 1 is 2, 2 is 2, 2. This is electronic configuration. If you do the boxes, the electrons completely box, no, it is completed. With 2s2, that's what completely. It is not at all very good. 2p. 2p, 3 orbitals are there. 1, 2, 3. 3 orbitals are there in 2p. Here only 1 electron is there. It is in a ground state. At the excited state, we may get this, it may go there. So there is a vacant, this is called vacancy. Vacant b orbital, vacant 2b orbital. This is called 2b orbital. This is vacant 2b orbital. Here you are getting the lone pair electron. This is a vacancy. Electron vacancy. Electron. That's why boron is called the electron depletion species. In that box, the lone pair of electrons come to they are forming a new bond that is called a coordinate covalent bond. The bond is called a coordinate covalent bond. There is one branch of chemistry is there, coordination chemistry. The chemistry's name is a coordination chemistry. There you may find that the bond. There are how many bonds you know that is ionic bond, ionic bond. For any here, you will not mention anything. There is ionic bond. There is covalent bond CH4. This is a covalent bond. For this, you have right bond. This is covalent bond. Coordinate bond is like this. There will be a one donor and one acceptor. See, here is a donor atom is ammonia. BF3 is an acceptor. According to Lewis, what he say? Which donate the electron, but this is called the base. Donor. So this is a basic substance. Base. Whereas it is accepting the electron, but accepts electron, they are called the acid. So BF3 is an acid because it accepts the electron from nitrogen of ammonia. So this is the way is explained. So in a book, if you see boron trifluoride, electron depletion. That I mentioned how the electron deficiency is there. Here there has a vacant 2p orbital. Vacant 2p orbital. When it is a ground state, when it's the excited state, the electron configuration of boron here, one electron will jump to the excited form. Okay, after hybridization, the F coming here. This is a vacant. Okay, this is a lone pair. We come then forming the accept a lone pair of electron and electrons are donated with ammonia from new coordinate covalent bond. Coordinate covalent bond. This is called coordinate covalent bond. That aroma explain what we explain the aroma, the donor and acceptor. Who is donating towards whom? Here, nitrogen donating, so the aroma towards this. So you are right. You have to see mention the aroma, direction of the aroma. Nitrogen is a donor, boron is a acceptor. So after seeing this, we can come to the conclusion that whoever donates the electron, it is called the base according to Lewis. Whoever accepts the pair of electron, they are called acid. So we can give a differentiation between the acid and bases. Lewis acid and bases. Okay. It will be very useful to for your exam purpose. Those substances can act as a Lewis acid, or those substances can act as a Lewis base. First difference, first point of difference if we go. The acid, electron deficient molecules such as BF3, it should be electron deficient. Okay, like BF3 and aluminium, Cl3 and BF. So beryllium, the deficiency boron I mentioned earlier. Now I am going to mention B. What is the atomic number of beryllium 4? What is the electronic configuration? You want to write that 1s2, 2s2, 2p, 0, no 2p. So this is like this. This is valence 11, 2s2, 2p, 0. Okay. What is the compound? If you write in a box, type this is 2 electrons, known as 2 electrons. One, two, three. This is 1s level, 2s level, 2p level. Now, at the ground state, the excitation will take place. After the excitation, you will have this is inner cell, will not disturb. During the excitation, what is going to happen? Now, in the incoming F, this compound is beryllium. The incoming F is coming to donate 1 electron. So F, here also 1 F. Or there is a 2 like. Thus, beryllium is the electron deficient. Okay. So the electron deficient molecules such as BF3, aluminum chloride, and BF2 can act as a Lewis acid. So these are the vacant places. Okay. The substance, those who are having the vacant places in them, they can act as a Lewis acid. If you any substance given to you, you verify that write the electron configuration. If there is any vacancies, you fill it up. Then that is can act as according to Lewis. That is can act as a Lewis acid. Likewise, molecule with 1 or more lone pair. Say the lone pair exists. If you are rich enough to donate, you can act as a donor. Okay. For example, ammonia. Ammonia, how it can donate? In ammonia NH3, if you clearly write this lone pair is 2 dots will be. What is the 2 dot is there? That is a lone pair. Based, I will explain how the lone pair comes. You write the nitrogen. Nitrogen, what is the atomic number? 7. 7, if you write the electron configuration, 1s2, 2s2, 2p3. It's an ammonia. Nitrogen is like this. In the ground state, the excited state will be, if you write in the box, during the excitation, the hybridization takes this is nitrogen because ammonia having 3 hydrogen atom, that is NH3. All hydrogen will come up here, will bonding like this, here on hydrogen, here on hydrogen. So this is a valence level outside, valence level. Here 2 lone pair. Only these 3 are involving in the formation of ammonia. Ammonia formation, only these 3 orbitals are involved. This leftover, this is called a lone pair. Even though it is present in a valence level, they do not involve in a chemical bonding. That pair of electron is called the lone pair. Those substances, those who are having the lone pair of electron, they can act as a Lewis base. It can donate. So in ammonia, there is a lone pair. What is the water? Water, where is the lone pair, sir? If you see that in a book, they are not given. Even here also. How I written the nitrogen, if you write answer like this, you will get that lone pair. Likewise, to that alcohol, what is the formula for general formula alcohol? ROH. ROH. Here the lone pair is there. Then ether, ROR, they get ROR. They are also lone pair in oxygen atom. They can involve in a body. Then amine or NH2 or NH2. Here this is a lone pair, isn't it? Lone pair. So the substance they are very rich of electron. They can act as a Lewis base because they can donate that lone pair towards the electron deficient pieces like a boron and beryllium. Okay, the first one is clear for you or not? Whether who can act as an acid, who can act as a base. According to Lewis, the electron deficient pieces they can act as a electron deficient pieces they can act as a Lewis acid. Then Lewis base. Then point number 2. What is the point number 2? All metal ions. So simply we can say cation or electron deficient pieces. It will mention as a plus symbol. Okay, that is electron deficiency. It is mentioned for the electron deficiency. All metal ions. For example, Fe2 plus, Fe3 plus, Cr3 plus, and Cu2 plus, etc. All can act as a Lewis base. Likewise, anions. F minus, the minus is not mentioned properly here too. We have it F minus, Cl minus, Cn minus, SO2, SO4, 2 minus, they can act as a Lewis base. And then molecules that contain non-polar double bond. What is considered non-polar double bond? See, for example, SO2. This is a non-polar double bond. Then a CO2. This is a non-polar double bond. You are having. It's a polar or non-polar. They contain polar double bond. Polar and non-polar difference is there. Polarity is there. This is a polar double bonds. They are act as a Lewis acid. Whereas molecules that contain carbon-carbon multiple bond. Carbon-carbon multiple bond. Like ethylene, acetylene, they are act as a Lewis. Then point number 3. 3 is over. 4. Molecules in which the central atom can expand its octet due to the availability. So we have shown that availability. No, empty d orbital is there. The availability is there that they can act as a Lewis acid. Silicon tetrahedral SiF4, SF4, FeCl3. In this molecule that can extend the octet. There is a vacancy in d orbital. They can act as a. They can accept electron. Since they are accepting the electron, they can act as a Lewis acid. Then all metal oxides like calcium oxide, magnesium oxide, Na2O, all metal oxides are basic in nature according to Lewis. Then they can donate the paraffin. Finally, we are getting carbonium ion. Carbonium ion. Carbonium ion. There is carbocation, tertiary carbocation. Then this deficiency is mentioned, so it can act as a Lewis acid. Carbon ion. So minus is there. That can act as a Lewis. So these are the difference between the Lewis and Lewis bases. Who can act as. Then from this example and evaluate, we can come to the conclusion of this today's session. Let us say identify the Lewis acid and Lewis base in the following reaction. They are given a reaction. So from this reaction, what we need to do? We need to find where is a Lewis acid and Lewis base. What is the reaction? The reaction is identify the example. Identify the Lewis acid Lewis base in the following: chromium 3 plus and 6H2O. Chromium 3 plus, Cr 3 plus, chromium 3 plus, and then 6H2, 6H2. You are getting the coordination compound Cr H2O 6 times. Yes. So name this IUPAC name of coordination compound is studied in inorganic. Hexa aqua, hexa 6, hexa aqua, chromium 3, chromium 3, and hexa aqua chromium 3. Yes, Lewis acid is there. That is a chromium 3 plus is Lewis acid, and chromium 3 plus is a Lewis because chromium 3 plus accepting the para electron from water, so that is one who accept the electron, that is called Lewis acid. What is Lewis base? For example, if you take the elaborated form in a way like this. Okay, this is central metal atom, CR3 plus. See here, 6 water molecules are donating pair of electron to so this is the way how the donations take place. Okay. So it is acceptor, chromium 3 plus. So chromium 3 plus is an acid, electron acceptor. Water molecule is donating, that's a base. Then evaluate. Evaluate question, let us go. Identify the Lewis union basis following reaction. They are given a reaction. What is the reaction? Is that calcium oxide CaO, calcium oxide plus carbon dioxide CO2. You are hearing that calcium carbonate CaCO3, calcium carbonate. What is going to happen? Already we say the polar oxides can act as a Lewis acid. So this is a Lewis base. Metallic oxide, calcium oxide basic combination. So this is a Lewis acid and Lewis base. And then the reaction is given. See, the reaction, it seems to clearly explain that coordinate bond. Oxygen donating the para electron towards aluminium. So AlCl3 acts as a Lewis acid. Since it donate the para electron, the ether, donating the para electron, this is a Lewis base. Then next question, evaluate 4. What is the evaluate 4 is given? Evaluate 4. H3PO3. So the boric acid can be written like this, H3. H3. This can be written like this. B. See, it is a very, very important reaction. Whatever when a boric H3PO3 accept the hydroxide ion from water is shown. When it's treated with water, it accepts the hydroxide ion from water. See, it seems like this. BOH thrice. So always easy tempted to have according to Arrhenius OH is there. You are simply you come to the answer that is a basic. No, it is an acid. It's a different case. Why it is acid? Because when it is dissolved, the H is not removed from here. When it is treated with water, the H will be removed from the water, not from the H3BO3. You are getting the reaction like this. BOH thrice and one more OH, it is 4 times. Plus H plus. The H plus comes from water, not from this. So the substance which releases the H plus, that is acid. Okay. Here, so how we are saying it's acid? That is based on the Lewis concept only we are explaining. Here, OH ion, they are given a question itself. Here accept the hydroxide ion from water. Hydroxide ion is donor. Hydroxide ion is a donor. It donating the pair of electron. Since it's accepting the electron pair from the OH minus OH, that's why it's a Lewis acid. That's it. So dear students, today we have seen for ionic nuclear introduction acid base nuclear reaction. That what are the different definitions given by the scientists for acid and bases? First, we have seen Arrhenius concept. In Arrhenius concept, we are saying that simply I am summarizing that Arrhenius concept H plus OH base giving acid and base, which is related to H plus and is acid. OH gives this base. Likewise, transitory protonic concept, that is it. Donate the proton, that is acid, it accepts the proton, that is base. From that, we are learning that the conjugate acid bases. And then from that, from Lewis concept, electronic concept, that is the substance which accepts the electrons, that is acid, which donates the electron, they are called as base. That's these three things only we have seen today. Arrhenius, transitory and Lewis concepts. What are the acids? What are the bases? If you have any doubt, you can ask me. Relevant to these three acid bases. Okay. Wouldn't you? Okay, student, you have any doubt regarding the acid bases based on the Arrhenius, transitory and the Lewis concepts? That we have seen only three topics we have seen. If you are having any doubt relevant to this, you can ask me. Everything clear for you? Okay, dear students, let us continue tomorrow. 10:30 acid basis. Okay.